So this is a walkthrough of the Telecaster style guitar that I made with a CNC machine, and it always starts with a drawing, some kind of model like this that can be used to generate the cam. So to create this, I started out with a drawing. This was pulled from a website called Electric Herald, and they have various drawings that are references of popular types of guitars. I don't know how accurate this is, but it was certainly something that I could work with. So I grabbed a screenshot of one of the drawings, cropped it, brought it in here, scaled it to the proper dimensions based off of some of these inner dimensions that they have here, and then traced the outer profile. So that outer profile of the guitar is made up of, I believe, 3 curves. There's a spline curve that makes up this side. There's a spline curve that makes up this side, and then some straight lines to make up the straight parts of the neck and the attachment for the neck. So most of the rest of the guitar is based off of this, and using this drawing to give me a rough location of where some of these openings should be. I started out with actually everything else is used from measurements. So I took measurements of the pickups that I have and measurements of the electronics that are going in here to give me precise dimensions of what these cutouts should be, so that there's a proper relief on the outside without any slop in there. So it's really custom made to the electronics that are going to be used in the instrument. The next one here is there's a circle sketch here. So this circle is defining the underbelly cut that is seen here. So there's a circle which is this, and from there is a profile that is swept along that circle to generate the cutout for that belly cutout. This was all just done by eye and by feel. Maybe you have a reference somewhere that you could measure, or just eyeball. It doesn't matter all that much. Same thing with the arm cutout here. There is a drawing which gives me the general angle that's going to be cut through, and then there is a profile that is created orthogonal to that line, and then this profile is swept along that line to cut out the arm profile. The neck is generated from another model. So the neck itself, I didn't have physical access to it. So I had the person who owned the neck take some very precise measurements with a micrometer to allow me to model the general profile of that neck. The only detail in here that was somewhat critical was this dimension here. Actually, it's all critical, but to figure out what some of these radiuses might be, just take a lot of measurements, and through constraints you end up making a very accurate model of that neck. And then that neck is used as a Boolean operator to remove the material for the neck to fit in from the body. So that's put in place, properly dimensioned based off of some reference, which Yeah, again, it might be by feel. Maybe you have one of your own, or you're just eyeballing it. Really, once that neck is put in place, especially this second pickup cavity, because let me see if I have that sketch. Some of this bridge is a unit bridge. At least the ring that goes around it is also the bridge itself. So the dimension from here, precisely where that string needs to be to the nut is the key dimension. So we have to make sure that that's all accurately put into place. These tabs were somewhat of an experiment. I was going to, and I didn't end up using this, but I was going to use these tabs as indexes that I could visually put on the table. So rather than using indexing holes and pins, I was going to put these on there and then draw lines on the table. I ended up making index marks. The back was machined first. Let's go into manufacturing process. So the back was machined first in this orientation. So my origin was right here at the center of where the neck attaches. Interestingly, it's not the same dimension from here to the top or here to the bottom as it is from here to the top. It's okay, it still fits on the table. So here's my origin, and that origin was put into my CNC software. So every time I zeroed the machine, and I did that a lot. Every time I zeroed the machine, it would go to the precise origin point, and then everything was machined from there. So that first operation is that facing operation to just flatten the material. I believe I have, for this one I just have one facing operation, but there's a lot of overlap between the swipes to try to minimize the lawn mowing patterns that sometimes show up. And so this was done several times because there was significant cupping in the blank. So I put the blank so the cup was up. That way it sits relatively flat on the surface. It was literally screwed down to the surface of my table and flattened until it was flat all the way around. The next operation was a pocketing operation to remove the material from the belly cut. This was done with a 1/4-inch bit to take this out with, I believe, leaving a 1/2 millimeter of material behind. One thing to note is I didn't just pocket out this. Usually if you do a pocket operation and you select this profile to cut out, it'll just cut out that profile and not any material around it. Well, with my next operation, which was a contouring operation, let me see, give this a better view. The contouring operation, I see, needed some relief around the outside, and I simply just removed more material than I had to in the pocketing operation, so that the ball bit, which is fairly substantial on the machine that I have, is not going to interfere with the material that was not cut out during the pocket operation. Next is the contour of the guitar. This was, I'm going to say, a mistake here. I should have just contoured the whole thing, but I was planning on cutting out 1/2 of it on one side, 1/2 of it on the other side, which is what I did. Although your indexing pins never are perfect, at least I have not had perfection with that yet. So you end up with a little ring around the outside that you got to belt sand off, but it's not too bad. The boring operation, so I located some points in the blank that is not going to be used that I can bore holes into. And then when I flip it over, the first operation is to bore those holes in the table with a with the same zero point on the other side. A little bit of an art sometimes to get that just right. On the other side, I wanted to make a point. I took out these operations. So these are the fillets to give it a nice round edge. So ultimately there's I believe a 1/2 inch round over, might even be less. I think it's just a 1/2 inch round over here. Well, I don't want that additional profile to be in there. In particular, when I'm trying to do like some of these pocket operations and allow it to detect where there are pockets, if you just take those out, or in this case, you can suppress that feature, it makes your manufacturing process much easier because you don't end up with certain things that might make it challenging to do your cam work. So yeah, if we go on the front side, flipped it over, faced it until it was flat, and because the 0 point is here, when I do that final facing operation at the proper depth, I'm going to get exactly 1.75 inches of thickness. So since it's indexed zeroed here at the table, that'll give me a very precise depth. The boring operations actually is this drilling operation here that was used to drill that. In the actual process, we drill that first. Next is the pocketing operations for this side. Similarly, you can see I'm removing more material than I have to give me some clearance for that next operation, which is that contour operation, just to make sure I don't hit the material accidentally with the ball nose bit. And that process, I was very happy with how this worked out. So I created a custom sketch where I projected the profile of this onto the surface of the sketch, and you create an offset from there, and that gives you a little bit more area to pull out. And then in the manufacturing process for this pocketing operation, if we edit that operation, you can see here that the machining boundary is set to selection, and the selection is that sketch that I cut out. So when I do that and really allow it to just bore out all the material that is within inside that machining boundary, that'll give me this extra relief around here. This is a new thing that I added for this particular build. Worked out really well. I am definitely going to use it again. Routed out the pickup cavities and the electronic cavities. Again, this was measured from the original pickups that I'm going to be using, and then once this was done, I checked it to make sure that the pickups fit just right. Sometimes it'll be undersized, but it worked out really well. I do the neck separately because it is so critical. Just in case there's some sort of issues with doing the pickup cavities, a misstep or something, I don't want to have to. I don't want to carry over that error all the way out to the pickup or to the neck cavity. So the neck cavity is routed out here, and this was actually when in the blank that I have, there's enough space here. There's an opening here that allows me to dry fit the neck into here. Because it doesn't always fit. So I have a second contour operation to just go around the outside. So if the neck doesn't quite fit, you just barely kiss that edge. sometimes even just running the same contour operation without any negative stock to leave will give you the fit that you need. And finally, there's the last contour operation. And I mentioned the bit that I have available is, I believe, a 2-inch bit, which will allow me to cut all the way through from top to bottom. So if I were to do this again, I would use this side of the guitar to be the main frame of reference, and just do a contouring operation down through the entire depth of the guitar. When I do this, I don't do any tabs. I know most people have tabs, but gosh, this is done with walnut, which is really heavy, and I just I baby the operation. So when it gets down to doing that final contour operation on that, that final 2 millimeters or whatever we're removing at a time, I just I do what you're not supposed to do, and I put my hand into the machine to hold down the piece to the table. Don't do that. Don't try that at home. So that's my guitar. I did create another profile to also widen out the pickups if I needed to, but the first bit worked just great, so I didn't end up using it. So there it is. Like I said, I don't really know what I'm doing, but this is the third full guitar that I've made, and like I said, each time you learn some new tricks and get a little bit better at it, or not. Maybe you try something that doesn't work. It's part of the fun. So keep cutting, stay safe, peace out.